Hello everyone, welcome to my channel. In today's lecture, we are going to solve the exercise questions of Unit 1, Physical Quantities and Units. This chapter looks very simple, but it builds the foundation for all of physics because every physical quantity, equation, and experiment depends on the correct units, measurements, and calculations. In this video, we will solve question step by step and I will focus on explaining the approach so that you can solve similar questions yourself in exam. Before going to solve a question, we saw we see a rapid revision. Last time we see units, errors, and vectors concept. Let's take some rapid revision and then we will discuss problems. So start with units. In units, there are seven base units: 5 kilogram, mass, length, time, current, and temperature for AS level, and rest of two amount and luminous intensity for A level. And thumb rule is write the unit. Okay. Now we have a here scale from a picometer to terameter. So keep in mind that, and we have a value figure, numerical magnitude, and give a unit. So write like this, not only 27.5, write unit always. Okay. Now we also see that anatomy of balance equation, which we do example on work is equals to kinetic energy plus potential energy. Okay. We see in the our last video. Now it is called homogeneity. If any equation which do not follow homogeneity, it is not a equation, right equation. It must be follow the homogeneity. Okay. It is about part one, which is units and homogeneity. Now, in two, we have uncertainty and errors. We see a systematic error and random error. In systematic error, we see shifts all the reading by fixed amount, which is not accurate, but it is precise value. Now, how to remove this error? By doing subtract error, and now this is the instrumental error, and we also see a random error which is caused by human or sometimes uh, environment, which is some kind of accurate but not precise value, means this is a scatter readings. Okay. Now go on, we have a what are you doing with data. So we have to calculate the final uncertainties, which doing by three ways depending on what in the questions. Okay. First way is the x is equal y for adding or subtracting uncertainties, and we got like this formula. And the second one is the multiply or divide. Now we can calculate by this, and the last one is for powers, and we have this kind of formula. And this is all about uncertainties and errors. This is a part two. Okay. Now last part, which is vectors and scalars. We have two part in physical quantities, and some physical quantities are scalars, and some another one is vectors. So in scalars, we only mention magnitude, not direction. Okay. Uh, the scalar quantities which are speeds, mass, time, energy, like that. And in vectors, we have to mention magnitude as well as the direction. Okay. The in the vectors, they include velocity, weight, force, and momentum, like physical quantities. Now we also see adding a vector. Okay, uh, for scalars, we have to add like we do in maths, okay? But in the vectors, the case is different. So we have a method which called a tip to tell method. So we also saw this method in the previous video. Now the last one is resolving a vector. We also resolve a vector uh, in two parts, which one is f cos theta and f another one is f sin theta. The vector in two components we will see in the problem. So this is all about we talk about the last video. First one is units, second is errors, and third one is vectors. Okay. Now we move on problems. Okay. Now we have 1 to 6 questions. The first one which says which of the following is an SI base unit? We already see there is 7 base units. We have to identify the which is the SI base unit. Okay, this is the ampere denoted by A, coulomb is denoted by C, Newton which is denoted by N, and joule is denoted by this. Ampere is the base unit of current. Coulomb is unit of charge. Newton is unit of force, and joule is for work or you can say energy. We have the last two, Newton and joule. They are called derived units because it is derived by some basic or you can say base units. We'll see in the next questions, but here the answer is ampere. Now, the second question, which is which of the following is a not SI base quantity? Okay, the quantity which is not fall in this 7 base unit, which is our answer. Okay, now we have a current. We also see a current is a SI base unit. This is not answerable. Now we have energy, then mass, and the temperature. We see in the 7 base units we have a current, mass, and the temperature. So our answer of second question is energy. Now, in third question, which of the following is a vector? Now, we have to identify the what is a vector. So, in option A, we have a electric charge, means which is denoted by Q, and momentum is denoted by P. Power, it is also denoted by P, and the work means denoted by W. Now we have to tell them vector quantity. Now we have seen in vector quantity we have a momentum. Okay. Now in the fourth question, which order of magnitude is represented by the prefix picometer? Now in we see in a large scale we have a 10 raised to minus 12 to 10 raised to 12. We have a scale. Okay. In that scale, we have to identify picometer. We tell 10 raised to minus 12, it is a picometer. So our answer of fourth question is 10 raised to minus 12. Now, in the fifth question, the speed of a sound wave through a gas pressure P, the density rho, is given by the equation V is equal to under root Kp upon rho, where K is a constant. An experiment is performed to determine K. The percentage uncertainties in V, P, rho are 4%, 2%, and 3% respectively. Which of the following gives the percentage uncertainty in K? Now we will solve this question in on next page. So we have a formula which is V is equals to K P by rho. Now we have to find what is the percentage uncertainty in K. So to find this, we have to do equation like both side we have to square K P upon rho and K is equals to V square rho upon P. Now we have to find percentage of uncertainty in K. Okay, we know the formula of how to get a percentage uncertainty. So by the formula we can write like this: delta K upon K, the uncertainty in K and the actual value of K. Now in the case of square cube, we have to multiply by 2 and delta V upon V means uncertainty in V and actual value of V. Same manner, we write rho density like this and the last the pressure. Okay, this is our formula and we have values here of percentage. Now we have to find only a uncertainty, not a true value plus uncertainty. Okay, so our formula will be like, so put the value of delta V, which is 4%, rho is 3%, and pressure has a 2%. Okay. So we got the answer 13%. Now we got the answer 13%. So the answer is fifth question is C. Now in sixth question, a girl walks at the speed of 1.5 meter per second for 1 minute in the direction of 35 degree north of east. How far east does she walk? Now let me draw a diagram, then you can easily get the question. Okay. So this is north, south, west, and east. Now question gives speed of the girl, which is 1.5 meter per second, and the time it took by the girl, which is 1 minute. Whenever we got the other quantity, which is different from the SI unit, we see SI unit of time is second. So we have to convert in the seconds. Okay, to convert 1 minute into second, we have to multiply by 60. We got 60 second. Now read the question. In the direction of 35 degree north of the east. What does it mean? Means you walk in northeast direction. Okay, this is the, you can say, distance vector. Okay, displacement vector. Now they give a angle, but which angle? This or this? Now read question carefully. north of the east. North of east. So north of east means this angle. Okay. So which is like this is a 35 degree. This is the displacement vector. Okay. And what we have to need is how far east does she walk? Means we have to find this value. Okay. Now here we use resolve of vector d. Why? Because we have to find this. Let me give this is the x direction and this is the y axis. Okay. So we have to find the x component of d. So this is the use of resolve the vector. Now how we find? So for this we have we do cos theta. Cos theta means corresponding angle we denoted by DE. Okay, so DE upon hypotenuse. Hypotenuse means magnitude of D vector. Okay, which is write like this, or you also write like this only D. Now we know the theta value, which is 35 degree. Where to find D? So we write like equation like this: D cos theta. Okay. So the value of D, which is not given, we have to find. We know the velocity is equals to distance or displacement upon given time or taking a time. So we have to find displacement. So we have to multiply velocity into time. Okay. So velocity is 1.5 into what is time? Time is 60. So we get 90 meter. Okay. So put the values of D is equal to 90 into cos 35 degree. You can do uh, cos 35 in your calculator, scientific calculator, and you got the answer is 74 meter, which is BE. So the value of DE means east direction. Okay, she walked. But if we want to find the north distance, so we have to do only this sine theta is equals to means I say here is dn. So write like this dn and d. By this formula, we can also get the value of dn, which is a north distance. Okay, this is all about sixth question. Okay, now we go on other questions. Now in seventh question, they give you three parts. In A part, first question is explain what is meant by the base unit. Now, uh, seven, a first question, base unit. A base unit, fundamental SI unit that is independent and cannot be expressed with the unit. Okay, so we have example here, which is a meter, meter, kilogram, ampere, second. So base unit is the fundamental SI unit that is not independent and cannot be expressed by some other unit. Now we have a second question. Give four example of base unit. Okay, I will give you this is the answer: mass, kilogram, ampere, second, temperature. Okay, from we have seven base units. Okay, SI units. You can write seven. Now in B, which says state what is meant by a derived unit. Now, in previous question, we mentioned two quantities, which is Newton and Joule. These two are derived units. So let's first we write the definition of it, then we give you example. So derived unit is formed by combined SI base units. Now let give me some example. Newton, okay, which is a unit of force. So we give a force like F is equals to ma, which is a quite famous equation uh, given by Newton's second law. Now, force is a vector quantity, A is rectangle, so I do arrow it. Mass is a scalar quantity. Now, we know the what is the SI unit of mass, which is kilogram. Acceleration, which is meter per second square. So we get the unit of force, which is Newton, but actually it is kilogram meter per second square. The other example, which is work, work unit is joule. Okay, joule. Now also uh, work is given by F into D. Means F is the force. Okay, force means this stuff kilogram meter per second square. D is the distance or displacement you can say, but the SI unit is meter. Okay. Now we got meter per seconds, meter square per second square means joule. These both are called derived unit, which is derived from base units. Okay. You see here, this is the base unit mass, acceleration. Okay. Now, here's the question B. Okay. Now, in C, for any equation to be valid, it must be homogeneous. Explain what is meant by homogeneous equation. We see in our last video we called homogeneous equation and must follow by all the equations in the physics. So let me first write a definition of it, then we will discuss. Now, an equation is homogeneous if all terms have the same units on both sides. We take example work is equals to kinetic energy plus potential energy. Okay. In my previous video, we see step by step why we call this a homogeneous equation. Okay. So now the next says the pressure P of an ideal gas density rho is given by the equation one third rho c square. Now the c square is the mean square speed. Okay. You can say RMS speed. It is a quantity measured as a speed square. Use base units to show that the equation is homogeneous. So let's find, or we have to prove that the equation is homogeneous. So to prove this equation, we have to take left hand side, which is P, and RHS, which is one third rho into c square. We have to show that LHS is equal to RHS. So what is a P? P here is a pressure. Pressure is given by force per unit area. Okay. So pressure P is equal to F upon A. So we have to find the SI unit of pressure. For that, we know the force has a Newton SI unit and Newton is given by kilogram meter per second square. Here A is area of the any surface. Okay. Area means meter square. So we get SI unit here is kilogram. This is a constant and second square into meter. So we write LHS is equal to kilogram meter second square. Now for RHS, we have one third rho c square. Rho, rho means density. Density is given by mass per volume. Okay, okay. Now mass means kilogram. SI unit. Volume means meter to meter to meter. Okay. So kilogram per meter cube, the unit of density. Now c square. They give in answer question. They give a treat like a speed square. So speed, you have to square it. What is the unit of speed? Speed means meter per second. We have to square it. Now here omit is one third because it has no SI unit. So we left with kilogram meter cube into meter square per second square. And we got kilogram meter into second square. From equation 1, Question 2. We can say that LHS is equal to RHS. Hence, P is equal to one third rho C square. Here we prove that this equation is fulfill the homogeneity. Okay, this is the right equation. Now, this is all about question number 7. Okay, now we go on question number 8. They say the period T of a pendulum of mass m is given by expression T is equal to 2 pi under root I upon mgh, where g is the acceleration of free fall and h is the length. Okay, so determine the base units of quantity I. Now we have to find the unit of I. So first we write equation. Question 8, T is equal to 2 pi under root I upon mgh. So we have to take a square both side. We got 4 pi square I upon mgh. So all the stuff move into the this side. So we get t square mgh upon 4 pi square. We eliminate this 4 pi square because we have to deal with only SI base unit. Okay, so it since it has a no SI unit, so we can omit it. So we have like this formula. Okay, what is t? T is a time period, means second square. M is a mass. Mass means kilogram. G is acceleration due to gravity. Means it is acceleration, okay? Meter per second square. And h is height. Again, meter. Now, cancel this thing, okay? And we left with kilogram into meter square. Okay? We got the unit of I, which we'll ask in our question. Okay? It is called a moment of inertia, just for a knowledge. We deal in rotational mechanics. Okay, this is the called moment of inertia. Okay, now this is the all about question 7 and question 8. Now we go another question. Now we have a question number 9. It has a two part A and B. So in the A part, determine the base units of work done and the moment of force. Okay, we have to find the base units of work done and the moment of force. Let's find out. So work done is given by F into D, means we also know force is a unit of Newton. So we can write second square into D. D means meter. And we got kilogram meter square per second square. Recall this equation, which is called Joule. Okay. Now another quantity is moment of force. Okay. Now for two, moment of force, which is also called a torque. Okay. We see this quantity in a rotational motion. Okay. Now torque is also given by F into D. So this equation and this is the same. Okay. So we get the same. SI base unit. Okay. So we got this SI unit of work done and moment of force, which is called torque. So we done this question. Now B says explain why your answer to A mean that caution is required when the homogeneity of equation is being tested. Okay. It says, can we write like this? And do torque, torque denoted by tau. Okay. Can we write like this or not? Which one is right? Here we see they have same SI unit. Okay. So can we do call the same work is equal to torque? This is our question. Okay. So if we have to give answer on this, we have to find fundamentally on work, definition of work, and tau means torque. So let's write the definition of work and tau and try to understand is it same or different. So here I write definition of work. Work is said to be done when the force applied to an object produces displacement in the direction of the force. Okay. So let's suppose here is a body. Okay. Anything block or something like that. We have a surface here. If we pull push something by a given a force, it moves in this way. Means it do some displacement. So work is fundamentally the general equation. You can say F dot D means FD cos theta. We will see in next our videos what is a dot product and what is a cross product. But today, this time you have to remember this definition and what does it mean. Okay. Now we talk about torque and start with its definition. Momentum force is the turning effect produced by a force about a pivot or fixed point. Okay. So it says the torque is turning effect, okay, produced by a force about pivot or fixed point. So let's understand in this slide. Means this is a fixed point, okay? And we have to force. This is the rod, okay? Rod is fixed by one point, okay? This is the movable part. Now, if you exert some force on this part, and this is a fix, okay? Fix. Now, the distance of the fixed point and the force, which is R, we will discuss in detail in our rotational motion, okay? So take a brief concept of torque here. Now, if we force in this direction, it goes like this. It do it do some rotational motion, okay? Rotational displacement, not like a linear one, okay? Now, torque is fundamentally given by like this: R cross F means RF sine theta, okay? This is a kind of a different situation than here, okay? So we cannot say the work and torque is same. Instead, still their assignment is same, but the physical meaning, actual meaning is different. So the answer B is this one. Now we go on 10th question. Distinguish between accuracy and precision. Now, 10th question is accuracy. What is the definition here? Means how close a measurement is to be true. Well, suppose take some example. Suppose the actual length of the scale is about 10 centimeter. Okay. Uh, Suppose student A takes some measurements and he got length like 9.9, 9.9 centimeter, 10.1 centimeter, and 10 centimeter. He took three measurements and he got three different values: 9.9 centimeter, 10.1 centimeter, and 10 centimeter. Now, from this, you can say it is very close. Okay. And it is exact. The third time, he got the same value to the actual one, which is called accuracy. Accuracy of this student A is very much, you can say. On the other hand, precision. Precision means uh, how how close, repeated measurements to each other. Okay. Let's the same scenario. The length is 10 centimeter. Okay. But here, student A got some like 8 centimeter, 8.5 centimeter, 8.5 centimeter. Here it is 8.5 centimeter. Okay. He got a result in three times same result. Means year one is, second is on. So he got the same result by three times. So it's his precision is very high, but accuracy is very low. Now we have true value is 10 centimeter, but he got the value 8.5 centimeter, very large or very far from actual one. Okay, by this you can say not every precision measurement is not accurate, or every accurate result is not kind of precision value. So this is all about the distinguishing of accuracy and precision. Now we go on to question number 11. The mass of coin is measured to be 12.5 plus or minus zero point 0.1 gram. The diameter is 2.8 plus or minus zero point 0.1 centimeter, and the thickness 2.1 plus or minus zero point 0.1 mm. Calculate the average density of material from which the coin is made with its uncertainty. Give your answer in kilogram meter per cube. Okay. So now we have to calculate the average density. Now uh, let me write density rho, which is given by mass per volume. Okay. So here we got coin. Okay. It's a kind of a cylinder kind of structure. This is the thickness and this is the diameter. Okay. So we have to find volume first, and then we have to put here, and we got the density. Now the volume, it is cylinder, is given by pi r square h. Pi is a 3.14 value. R is the radius of the cylinder. H is height. But here we get the diameter, so we have to replace radius by diameter, and H is we call as T. Now this is a number 4, and here D is 2.8. Here we take a true value, not uncertain value. At the last, we add uncertain value in that part, and we got the answer 2.8. Now squared divided by 4, and the thickness, which is 2.1, and the answer is 1.29 into 10 to the power minus 6 meter cube. Now we got the volume. Now go for density. The mass here given is 12.5 upon 2.9 10 to minus 6. And we got here, it is in gram. Okay. So this is 2 in kg. Okay. Take mine 10 to minus 3. And we got the answer about 9.7 into 10 to the power 3 kg per meter cube. So here we got the answer, but which the coin is made with uncertainty. So we have to find uncertainty as well. So to find relative uncertainty, we have a formula here. Delta rho by rho, delta m upon m plus 2 delta d by d plus delta t by t. It is coming from like this. The formula is m upon pi d square by 2 into t. Here we omit pi because it has no uncertain, because it is absolute value. Here 2 is also absolute value. Now From this, we can put the values. Delta M here is a zero point 0.1 into 10 raised to minus 3 kg. Delta D is zero point 0.1 centimeter and delta T, which is zero point 0.1 mm. So after the putting the values of these, we got the answer point 0.27127. And now to find delta rho, 0.127 into rho means we 9.7 into 10 to the power 3. And we got the answer 1.2 into 10 to the power 3 kg per meter cube. This is uncertainty. Okay. Now, the final answer rho is equals to 9.7 plus or minus 1.2 into 10 to the power 3 kg per meter cube. Always write the unit. Otherwise, marks will be deducted here. Okay. Now, this is all about question 11. Now, in question 12, A part, distinguish between scalar and vector quantity. Now, we have question 12A, write scalar quantity. A physical quantity that has magnitude only with no specific direction. We took take example of mass, temperature, and time. Okay. On the other hand, vector. The definition is a physical quantity that has magnitude as well as direction. Okay. Now, in this example is velocity, acceleration, etc. Now, this is the definition of scalar quantity and vector quantity, which we'll discuss in before previous video. Now we go on question B. The mass of weight 120 Newton is hung from two strings as shown in figure 1.35. Now, see this figure and try to understand. There is a mass of 120 Newton. Wait, there's a string A, string B, and string A is a 40-degree angle between this this direction and string A. So the direction of tension in A is like this, TA, and the tension in B string is TB. Let's suppose. Now, write a read question determined by scale drawing or by calculation. The tension in RA and RB. We have to calculate TA and TB values. So, draw same diagram as we got. Here is a TA, here is a A string, and here is a B string. And it's 120 Newton weight, okay? And this angle is 40 and this angle is 15, I guess. Okay, so if find TA and TB. Okay, so in this question, we are doing resolution of component into direction, which we'll discuss in a previous video. So let's do for TA. Let's understand like this. This is a direction and this is a TA direction. Okay. Let's suppose this is X direction, if this is a Y direction. Okay. And our angle is here 40 degree. So if we have to find Y component and X component, write like this. Means cos 40 means cos 40 means Y component. Let's suppose TAY upon TA. Now we don't know TA or TAY also. So try some other approach to solve this question. Okay. Now by doing this, this is also direction. This is also direction. In this direction, we have resolved TA in this direction and this direction. 40 degree here and TB this direction and this direction. By saying this is the opposite direction, and the whole system is in equilibrium. That means this component, let's say TAX and TBX, it is equal. Means we can write TAX is equals to TAY. Now let me erase these things. From this, you can write TA. This is the opposite angle, okay? So TA sine, we have to use sine 40, and TAY means this is opposite angle also. T, TB sine 50. We know the values of sine 40 and sine 50, but unfortunately, we don't know T and TB. So by putting the values of sine 40 and sine 50, we got value of TA like 1.1918 TB. Let's name is equation 1. Okay. Now in step 2, this is step 1. Okay. In step 1, we got the first equation, which is TA is equal to 1.1918 TB. Now in step 2, we got think like here TA cos component and TB cos component in same direction. Okay. Means in this direction, it is also a static equilibrium. So the force due to this 120, it is also force, not a mass, because it is Newton. Okay, means W is equal to mg. You have to equate this force due to 120 is equal to force of A cos component and FA FB cos component. Okay, so that it is in equilibrium position. Otherwise, it will moving like this. In first step, we saw there is a equilibrium mean of sine component of TA and sine component of TB. Okay, by it is a static point, static equilibrium, so that we can equate this. That means there is no horizontal vibration, you can say vibration or displacement. Okay. And for vertical direction, we have a coarse components of TA and TB. Okay. We have to add it. TA cos means 40, TB cos 50, which is equal to 120. The force of 120 Newton is downward direction, and this by these two components, the force is given to upward direction. So we have to equate it. Okay. Now we know cos 40, cos 50 value, and put this cos 40 and cos 50 value, and we got equation like now. There's a one thing here. We have a TA value also. Okay. So put this value instead of write TA. So we got the value of TB is like 77.1 Newton because there's a only one quantity which is unknown. Okay. Quantity is known, TA, which is coming from this equation 1, cos 40 also known, and cos 50 also known. So we get the TB. And now put this value in this equation. We got TA. We got TA like 91.9 Newton. Okay. The first answer we got tension in RA and RB. Okay. Now in C part, use your answer B to determine horizontal component of tension in RA and RB. Comment your answer. For this, we have a C part. We have to find horizontal component HA and HB. From this direction, this is a horizontal component of A, and this from this you can write HA is equals to HB because why? Because it is static equilibrium. Okay, we know HA means TA sine 40, which already discussed here. TAX, TA sine 40. Put the values of TA here. We got the TA and sine 14. We got 59.1 Newton. The direction of force, it is pointing to left. Here, it's a pointing to left. Okay. Now find HB pointing to right. HB, okay. TB sine 50, which is also same value and pointing to right. Here, you cannot write like this. This is absolutely wrong because the direction of both is different. One is pointing to left and one is pointing to right. But instead of write like this, you can write HA is equals to HB, or the magnitude of HA and the magnitude of HB is same. It is right, but it is completely wrong. Comment your answer means, as we know, this is in equilibrium. The horizontal component is also same. the direction is opposite. So the effective horizontal force or tension, you can say here, which is not appropriate word, tension is zero because they have a same value but in different direction. First is in this direction and another one is in this direction. But the value of same HA, HB. So they are cancel each other. So the effective force or tension is zero here. Now this is all about question 9, 10, 11, and 12. All right. So we have completed today's set of exercise questions. These questions covered the main idea of physical quantities, units, uncertainties, vectors, and dimension analysis. There are still some remaining problems which we will. Thank you for watching my video. Subscribe for more physics lecture.